Okay, here's our bond. With this, our objective. We want to predict bond type, and there are three types of bonds that we're going to be able to predict from electronegativity values. All right, there's if the electronegativity difference is 0.4 or less, then this is ionic. No, non-polar covalent. If it's in here, it's polar covalent, and it's above 1.7, it's considered ionic. Now, as you move this scale, ionic character increases, and as you go this way, covalent character increases. All right. Now, all bonds are a mixture, meaning just because it's in this region doesn't mean that they're not necessarily sharing the electrons. Now, to predict the bonds, you can use that. You can also use just the element's location from the periodic table. Let's say I've got this element, which is sodium, and this element, which is chlorine, a metal and a nonmetal, equals ionic. Nonmetal A and nonmetal B polar covalent. Okay? And finally, the same nonmetal that's where I have non-polar covalent. So a nonmetal and a metal, something here and something from here, nonmetal metal, that is ionic. Two different nonmetals, that's polar covalent, and two of the same nonmetal, this is an A. Two of the same nonmetals, that is polar covalent. Sorry, non-polar covalent. All right, let's look at some examples. Carbon monoxide. Well, to do this, you'd have to, the best way, look at like a Lewis structure along with it, but in terms of electronegativity, this is 2.5 and that's 3.5, so the electronegativity is difference is 1 polar covalent. All right. HCl. Well, H is 2.1, 3.1, eneg, delta eneg is 1, therefore polar covalent. All right. Two different nonmetals, polar covalent. There are some exceptions, but that's like a general trend. All right, if you look at a book, something like this, what type of the bonds? You only can look at a bond between two different atoms. So there's total of 7 atoms in this. So you'd have to draw a Lewis structure. I know the Lewis structure because I've drawn it before, and you probably do too, because you are observant and clever. There. So now we can look at it a little more specifically. Every one of these bonds is actually a polar covalent bond because everyone's electronegativity difference. This is a 2.1, this is 3.5. Sulfur's value, I'm going to have to look it up real quick. I just looked it up. It's 2.5. Okay. There. That is a, so these are polar covalent bonds, all of them. All right. Now, all right. How about MgF2? Well, F is 4. Magnesium's electronegativity, I don't know. I'm going to guess it's around like 2.1. Way off, it's 1.2. Therefore, the electronegativity difference is 2.8. Therefore, this is ionic. Okay. What about F2? Well, 4 minus 4 is 0. Therefore, this is nonpolar covalent. Now, but in actuality, though, when it said like all bonds have different variance of constant, it doesn't mean that these electrons are always directly in the center. It means that they're going to move around, and it could, one end could polarize a wee bit, and that's how you get London dispersion forces. All right. Now I want to talk about one bond in particular. That's this bond, carbon-hydrogen bond. 2.5 carbon minus 2.1. That's a 0.4 difference. Okay, this is right on the cusp, right? It's right there. It's right on the cusp of being nonpolar covalent or covalent. We are, for the sake of this class, going to make or label as nonpolar. All right, there you go. So the bond types are ionic, polar, covalent, nonpolar. This is a big, medium, and small. Greater than ionic is greater than 1.7. And two examples of that are like sodium and sodium chloride, non-metal metal. 1.7 to 0.4 is polar covalent. That's like carbon monoxide, and 0 to 0.4, that's a carbon hydrogen bond. All right, thank you. Let me know if this helps. Bye.